All right, happy welcome back from prom day, I guess. I'm glad everybody is reunited safely. Lots of memories made, and still lots of photos to catch up with on social media. All right, so many, yeah. Okay, we are on example 9. We are going to try to finish today because we got 6.3 with more identities waiting, and even 6.4 with even more identities waiting. The AP exams start next week. There is a STAR EOC whatever test this Thursday. Uh, this Thursday. Yep. No, is it next Thursday? It's next Thursday. Oh, it's next. It's next Thursday. Is it next Tuesday? It's next Tuesday. Okay. Hang on. It's next. Yeah, it's next Tuesday. You're right. Next Tuesday. So I won't see y'all on next Tuesday because I'm actually giving that exam. If you have an AP exam on Tuesday, you're taking the makeup exam. As it was pointed out this morning by Amanda R. I won't say the R stands for Rogers. The AP exams will kind of interfere with our prime test over 6-1 to 6-4 date. So I haven't talked with the Precal boss yet, but we'll probably wait till after AP exams, that first week after AP exams to test over 6-1, 6-4. So we'll kind of slow play it during AP exams, give y'all chances to practice, and practice some more, like more practice, like extra practice. Like when you go to the Asian Center, like, can I get that spicy? It already is spicy. Okay, can I get extra spicy? Already is extra spicy. All right, can I get extra spicy? They're like, oh, okay, we can do that, right? Okay. Do you ever do that? You ever do that? Like you get one of those dishes and it has like that little pepper next to it, and you're like, oh, that's the spicy one. But you want it really, really spicy, and they're like, no, no, you don't. It's already really spicy. And you're like, yes, I do. Yes, I do. Please triple the amount of spicy. And they're like, it already comes like that. I'm like, okay, well then sextuple it. And they're like, whoa, this is not that kind of establishment. All right. All right. Right. And then Robert Kraft goes somewhere else. All right. So, okay, one person. Yay. All right. Prove the following identity. Cosine to the fifth equals that. Now, you may think that the right side has a lot of information, and it does, but the left side is a dense nucleus. Look at that. It has a power of 5 in it. So, starting on the left to right, there's really no correct answer here. It just comes down to whether you are more comfortable factoring or expanding. And I'll tell you that from looking at that worksheet y'all just did, a lot of y'all, when it comes to factoring, like, I don't know how. And I'm sorry, okay? You're just going to have to learn how. So you tell me, what side do you want to start on? The right. Okay, good. So if you're going to start on the right, if you notice, there is a squared term and a non-squared term and a constant. And by squared, I mean you have an even power of 4 and another power that is half its size. It doesn't always have to be bland old sine to the first and sine squared, or x to the first and x squared. It could be any variable power, and then the other one is twice its size. That's a possibly factorable trinomial. So if you want, we typically write the sine to the fourth in the front, don't we? Would y'all do that? Would y'all write it in descending order? You certainly can. So let's explore that. That would be worth a whole line of writing because that would be the associative property of addition. So sine to the fourth of x, bless you, minus 2 sine squared of x, bless you, plus 1, bless you. Okay. Now this could possibly factor the cosine. I'm just going to leave it, right? Why am I going to leave the cosine? Because I already have one factor of it over here. I need to pick up 4 more because I need cosine to the fifth. So how does it factor? Well, what's the square root of sine to the fourth? Sine squared, sine squared. And now we're just looking for factors of positive 1 that add up to negative 2. Oh, how about minus 1, minus 1? That works, right? So it ends up being sine squared minus 1 quantity squared. You don't need to do that. You can leave it like that. Now, what is our goal? We need to get rid of the sine squareds and introduce some cosines. Oh my gosh, if you don't know already, how can we write sine squared in terms of cosine squared? Sine squared is 1 minus cosine squared, right? So you can either replace this sine squared with 1 minus cosine squared and then combine like terms, or you can go straight to the identity in your head or off to the side. Cosine squared plus sine squared equals 1. Is it okay to write those off to the side to make sure you get them right? Yeah. What is sine squared minus 1? Well, if you have to bring the 1 across to make it sine squared minus 1, that means you have to clear the cosine out from that side, which makes it what? Negative. Good. If you are off by a negative, you're off. You're not going to get that second check. Right? We're used to seeing 1 minus sine squared. But sine squared minus 1 works. It's just negative cosine squared times the cosine. Now that's good because we have factors of cosine instead of sine. Now we multiply together. What is a negative times a negative? A positive. So what's cosine squared times cosine squared? Cosine to the fourth. Bless you, bless you. Negative times negative is positive. So we get cosine to the fourth times cosine of x. And that step is needed because you're multiplying those two together. And then you multiply those and you get cosine to the fifth. So if you would have just had cosine squared times cosine squared times cosine, you would have gotten to cosine to the fifth. But you wouldn't have gotten that second check on the test. Because I follow every single line. And if there's an error in any single line, that is, it's not equivalent to the one above and below it, or you make some kind of careless mistake, you'll lose points, even if you manage to get the right answer. Okay? Yeah, absolutely. If you don't want to flip those terms around, you could factor it just as it is. That's 1 minus sine squared and 1 minus sine squared. Okay? And then you get cosine squared times cosine squared, or cosine squared to the fourth. So yeah, if you don't flip those terms around, you're not going to get a negative cosine squared, you're going to get a positive cosine squared. And so that's why I'm saying it's just a matter of how you do it. If you wanted to do it the way it was given to you, that's fine. Just make sure you're making legitimate replacements. Now, here's another way to do it. For those of you who like alternative methods, cosine to the fifth, I said, was a dense nucleus. Notice that cosine of x is needed on the far right side. We need that. So let's take 1 out. The rest of them, let's just call that cosine squared times cosine squared. Is that still cosine to the fifth over there? Yep. And now these cosine squareds, I'm going to replace using the Papa Pid that I'm comfortable with. 1 minus sine squared, 1 minus sine squared times the cosine that's there. And now instead of factoring, what am I going to do with these two? I'm going to expand it. So square the first, multiply and double, and then square the last, you get positive sine to the fourth times cosine. So if you want to do it that way, that's expanding instead of factoring. It works. Either one is the same. It's just how you prefer to do it. Know your identities. There were some people that came in this morning, didn't know their identities. If you have no idea what your identities are, you have no idea what your options are. You're just staring at letters and symbols on a page. So you're doing yourself a great disservice. So before you try to prove any more, go to the Quizlet apps, Corpy_S World, and practice, or have your parents quiz you, have your friends quiz you, have your dogs quiz you, okay? Whatever, as long as you make sure that you absolutely 100% know your identities. All right, any questions on number 9? All right, number 10, prove the following identity. Which side do you want to start on, left or right? Left? The left has more information, obviously, right? There's 4 trig functions instead of 2. And there is some obvious math you could do on the left. You see that? Because the right is 2 terms, the left is 2 factors. So you can actually expand the left side and see if it works down to 2 factors. So let's go ahead and do that. I'm not sure if it's the right thing to do, but I'm not going to sit here and just, be plagued with indecision while my life passes me by. All right? Hustle while you wait. Do something. Let's just distribute. Sine times tangent. First, outer, plus sine of x times cotangent of x. So don't forget your x's either. Plus cosine of x, tangent of x. And then plus cosine of x, cotangent of x. Okay? So the good news is, I expanded correctly. The good news is, I now have at least two terms on the left. Oops, I didn't expand the first one very well, did I? I was talking. The first one is sine of x times tangent of x. Good thing I double checked. Yeah, you could double check your work. Every one of those four terms should have two factors, and now they do. Okay, cool. Do it right the first time. Okay, any ideas now? Are any of those reciprocals of each other that we multiplied? Because anything times its reciprocal is 1. Not really. So if we have the product of two trig functions and we want to see what it might simplify down to, that's when you want to go down to the genetic DNA of every trig function, which is what? Sine and cosine. So let's do that. Let's see what happens. Again, I'm not sure if it's the right thing to do, but you know what? You should feel for kids from several years ago that were actually taking notes on paper. If they hit a dead end, guess what they had to do? They had to actually erase it like with a real eraser. And then their paper had remnants, and they had to, like a palpum set. They had to write over their old work. Oh my gosh, y'all just are like, erase, done, or circle, done, or whatever. So much easier. Y'all don't know how good you have it. And even before that, people had to do this like in sand on the beach with like a feather, before writing products were invented. And then the tide would come in and wash their work away, and they're like, oh no! Right? And then before that, they were like, me have rock. What trig proof, right? Oh, simpler times. All right, sine times tangent. That's sine of x times tangent, which is sine of x over cosine of x, okay? Plus sine of x is sine of x times cotangent of x. That's cosine of x over sine of x. Looking good, looking good. Plus cosine of x is cosine of x times tangent is sine of x over cosine of x. And then plus cosine times cotangent, that's cosine of x times cotangent, which is cosine x over sine of x. Okay, having such a good time. Oh yeah, we are. And now, does anything good happen? Well, let's see. This is like over 1. So over here, we just have sine squared of x over cosine of x. That's nice. Plus, over here, what happens if we put that over 1? Anything? Sines divide out. Yay, and we're just left with cosine of x. Plus, over here, put that over 1, your cosines divide out, and we're just left with sine of x. Plus, over here, you're left with cosine squared of x over sine of x. And now you're like, that must be the right side. Boy, oh boy. Okay, what to do? Any ideas? Do we have an identity? Sine squared plus cosine squared, can we call that 1? Do they have common denominators? Caramba. No, they don't. So we can't call that. So at some point you realize that, okay, I don't know what to do on the left. There's nothing that's real obvious anymore. It's already in terms of sine and cosine. Look over on the left side and try to do something over there. What would you do on the left side now? On the right side, sorry, the other left side. Put it in terms of sine and cosine. Yeah, I mean the left side, but like in terms of like if you don't know which side is which, or if you're like in Mrs. Lincoln's room staring at us. Right? Okay, good. Or just admit your mistake. Yeah, I meant right side. Thank you. Okay, now that's already looking so, well, yeah, a lot better. Now what? Any ideas? Any bright ideas? Start over? What would we do differently? Okay, how about this? Everything on the right is in terms of a fraction, right, Zach? You're multitasking, I hope. Everything on the right is a quotient, is a fraction. Two terms on the left are a fraction. Did you ever watch Sesame Street growing up, or was it already kind of defunded and not on that often? Okay, they had this little segment like one of these things is doing their own thing, right? They had like four windows, and three people were doing something similar, and the fourth guy was like shaving, or something. And you had to figure out which one was different. The first three guys were like jumping rope. I spy the different one, okay? Which two of these 6 terms on both sides are different? The cosine and the sine. So here's what we could do. Let us put them over 1 to try and make them look more fraction-esque. And now, let's try and get a common factor, okay? Because I got 4 terms on the left, 2 terms on the right. Let's see if I can't just get a common factor, okay? What would be the common factor on the left? We can't do crisscross applesauce here because we have 4 terms. What would be the LCM of cosine 1 and sine? Cosine, sine. Good. Cosine times sine. So I'm going to come through and I'm going to rewrite it. The first one, it has a cosine, so I need to multiply by sine over sine times what's already there. Sine squared over cosine squared. Oh boy. Oh no. Plus, this one needs both the sine and a cosine. So sine x cosine x over 1. Sine x cosine x times cosine x over 1. Sorry, I didn't get there fast enough. Plus, same thing over here. Sine x. Oh my gosh. Sine x cosine x times over. Oh my god. Is this the right thing to do? Oh my gosh. This just feels like we are getting so far away from what we're supposed to. But what else would we do? I don't either. No, I don't. I really don't. I mean, could we abandon it? Well, I mean, if we went back to the drawing board up to the top, what would y'all do differently? Right. I mean, we would either expand. Well, we've already done that. If we put it in terms of sine and cosine from the very beginning and then expand, it's going to kind of look the same. No, they should be. Let's see what we get. I'm not ready to give up just yet. In the top, if we multiply across, we get sine cubed of x, and then we're going to get plus sine of x cosine squared of x plus sine of x squared cosine of x plus cosine cubed of x all over sine x cosine x. Oh my gosh. Oh my gosh. Is right. All right, let's try and get a common denominator on the right. We can do crisscross applesauce here. It's sine x plus cosine x all over the product, which is cosine times sine or sine times cosine. Hey, look, the good news is, yeah. They're both one term now. Yeah, go us. And we have a common denominator on both sides. That's the same on both sides. So should we mess with the denominator? Probably not. So all I got to show is that the numerator on the left is equal to the numerator on the right. What the? Combine like terms? Can we, let's see. Or do we have like terms? We don't really have like terms. Can we factor by grouping in the top? Let's try factoring by grouping, right? Group these 2 rascals together. Group those 2 fellas together. I don't know what else to do. Let's just try it. We have a sine that's common. And when we factor that out, what are we left with? Sine squared x plus cosine squared of x. Plus, let's factor the second one by grouping. There's a cosine that's common. Times, let's see, we're left with the sine squared x plus a cosine squared of x all over sine of x cosine x. Sometimes you need to remodel your vertical line, so we'll do that now. All right, so I just factored by grouping. I had 4 terms, and I didn't know what else to do. Is factor by grouping something that we've learned in the past? Yes. Is it legal today? Of course. Anything you learn on the playground or in school or in church, it's all legal. Praying, is that legal? Sure, if it helps. Now what? Papa Pid times Papa Pid or Papa Pid. Papa Pid all over the place. That's sine of x times 1 plus cosine of x times 1 all over sine x cosine of x. And anything times 1 is equal to itself. So we get sine x plus cosine of x all over x times cosine of x. Now, when we look at the right side, is the order of the terms and factors the same? Yes. If the order were different, like if on the left I had in the numerator cosine plus sine, we'd have to go one more step and commute the terms or commute the factors. So did it work? Yes. Did it look like it wasn't for a while? Yes. Persistence pays off. So some of the strategies that we did there, well, we put everything in terms of sine and cosine. We got one term or several terms into one term by getting a common denominator, and we did that on both sides. And then factoring is always an option, okay? Always an option. Now, if you wanted to, you could have introduced something on the right side. And this is building it up. You could have multiplied by 1. What form of 1 would you have multiplied by? In hindsight. If you're looking at the left side and you're like, man, we got lots of sines and cosines over there. Let's try multiplying by a clever form of 1, which is sine squared plus cosine squared. And the bottom looks good, so I'm not going to mess with the bottom. It's already good. And then what could you do? You could FOIL that out. And if you FOIL that out, would you get what we got? Yeah. Okay? Yeah. But this requires some insight. But in hindsight, it doesn't look so foolish, does it? We know we can multiply by 1 if what we have on the left has a surplus of sines and cosines. Multiplying by Papa Pid, a clever form of 1, and you don't have to do Papa Pid over Papa Pid. Papa Pid itself is equal to 1. It's not so outlandish. Or remember some of your factoring techniques from Algebra 2. Factor by grouping. Okay. Why? Because you gave up and you didn't think it was going to be the right way to do it? No, I didn't get right. Oh, yeah, I know. That's why I bite mine down to a nub. I actually don't bite mine down. I pick mine down, or my wife clips them down. She says that when I play with the dogs, my nails usually scratch the dogs, so that's why. But my dogs get to keep their claws. In fact, my dog scratched me last night across the left side of my face. I mean, a mountain lion scratched me down here along the left side of me. I barely survived. Yeah. Persistence pays off. Some of these are going to be longer than others. And if you notice, we are nearing the end of the notes, right? And near the end of the notes, you can kind of expect them to be a little bit more intimidating than some of the previous ones. But the strategies that we've been looking at, incorporating, they remain the same, okay? Not all of them are going to be nice, quick 3 or 4 line proofs, okay? When you're at the end of your rope, right, they say tie a knot and hang on. That's kind of hard, right? Have you ever tried hanging from a rope, dangling from the end of a rope? It takes a lot of muscles to pull yourself up and tie a knot while you're hanging on the end of that rope. I mean, you have to be like Ninja Warrior to be able to do that, in which case you probably don't even need a knot to hang on, right? I would say if you're going to start hanging from ropes, maybe tie a knot in the end of it to begin with, right? Yeah. I'm just yeah, it's good life advice, isn't it? Oh, nails from prom. Y'all still got your prom nails going. Oh, yeah, you want to keep them. You want to keep them. Oh, sweet. I would have clipped your nails short for free. I have a big toenail clipper that I can use on big gaudy nails. Yeah. Yep. Yep. And I could have loaned you the dress I wore 12 years ago at a pep rally when I dressed in drag. I could have loaned you all that dress for prom for free. Hmm. Yeah. It's like a Hawaiian dress. It's like mainly pink with some white flowers on it. I doubt it even fits anymore. Yeah. It was thrift store special. But I keep it in my costume section of my closet. In case I ever need to dress up again. Although nowadays, it's probably unacceptable for males to dress in drag unless they're really transgender. So a lot has changed. So maybe I should just get rid of the dress. Anyone want it? Not guys. Well, unless no, y'all's dresses. It looked like the dress. It looked like the dress of the year was this one.
Oh.
Yeah, y'all saw that a lot of that dress. Like, whoa, that's pretty low cut. Yeah. There's an arm right there. There's an. Yeah, yeah. There was a lot of those dresses going around, and you're like, what the heck? And then you realize that there's like right here, there's yeah, there's mesh, right? Yeah, and it's like, okay, all right, yeah. And then there were a lot of people still wearing last year's style, which is a good style, with the belly button ring showing the two piece with the belly button ring or whatever. Yeah. Yep. Yep. And the guys, man, a lot of guys with the classic look of classic look of white lapels. Yeah, it was white. Yeah, it looked there was some good white was good. Yeah, and then gold chain. Yeah.
Oh, I had that popped
Yeah. See, all right. Hey, are y'all ready for the next one? Y'all done copying this? Any questions? Well, y'all were copying it as I went. I was hoping because I don't just like it'd be great if I was like, all right, here's your notes, guys. Copy it down. I'll be over here designing dresses. Yeah, wouldn't it? And I'm like, there, you need to know that for the test. And you're like, is it too late to drop? Right? I walk you through each and every line. We talk about strategies on each and every line, what to do on each and every line. All right. Yeah. Okay, there's room. Add pages. All right, we're going to conclude with the Kodiak Grizzly Bear. You got your grizzly, you got your bears, and then you got your grizzly bears. Grizzly bears are the grisliest of all bears. That's why they're named the grizzly bear. They're probably the most feared. And if you think that only black bears can climb trees, wait till a grizzly bear climbs up a tree and eats you. Okay. If you want to see the fierceness of grizzly bears, watch a documentary called Grizzly Man. It's man, the guy lived with grizzly bears for years, and he said, hey, these guys are misunderstood. And at the end of the documentary, he and his girlfriend get eaten by a bear, and it's live on tape.
No, it is not.
It is, but they don't show the video. They only play the audio. But you can, because that's better. Yeah. So, yeah. Have you seen it, Peyton? No. Yeah. You can hear the screams, and you can hear the grizzly bear burping and stuff. It's just like it's horrible. Grizzly bears are fierce. Now, has anyone ever been to Kodiak Island in Alaska? Probably not, okay? You probably see Kodiak Island from afar. Kodiak Island in Alaska is a remote, isolated island where the grizzly bears roam free, and there's a surplus of food there. So these grizzly bears over time have grown big and fierce and mean, and they're not tourist friendly either. So the biggest grizzly bears, the most fierce grizzly bears, are the Kodiak grizzly bears from Kodiak Island, Alaska. And look, this came up on my Insta. Can we call it Insta? Is that? If I say Insta, you don't think I'm talking about like instant potatoes? Okay, Instagram. I follow Our Planet Daily. It's a great one. And this came up just the other day. It's not on yours, but I put it on mine. This came up the other day. It said Alaska, right? And so I clicked on Alaska, and it showed me where Alaska was on the map. And I'm like, oh, that's the special part of Alaska right there. And this is what showed up. Oh my gosh! That's a big boy! That's a big boy! Look at that! Look at that thing! He is the boss, man. He's not even standing. But gosh, look at that. And look at this guy, Carl Donahue. He has like a super duper quadruper zoom lens. He's like taking this picture from like Idaho, you know. He doesn't even want to be near this guy. Idaho, by the way, has grizzlies, but not this big. Look at that big boy. I mean, there's nothing perspective to compare it to, but if you were to draw, these are trees. These are actually trees down here. These aren't blades of grass. Those are trees. Here by comparison is what a man looks like, okay, compared to the Kodiak Grizzly. See that? There's a man by comparison. Look at that. That is a big boy, right? So that's a Kodiak Grizzly. And it says, this, my friends, is an every man for himself type of animal. Kodiak bears can reach up to 1,400 pounds and 11 feet. And they throw this in here with dark black eyes, similar to great white sharks. Oh, they have no soul. Tag someone who should see this. So nice of this bear to quickly pose for a wilderness photo. Even bears like the gram. So should I call it the gram or should I call it Insta? Never call it the gram. Okay. Okay. Never call it the gram. All right. So let's conclude with this one. Yeah, I know it will be because I just found it it just came up the other day. I'm gonna put it on next year's notes. It'll be in there. And look at the guy from Discover Sharks is like, what is that emoji? That's like praise. Oh, praise. Oh, that's praise. Okay, I thought that was like the wind symbol with the fingers going back and forth, like wow, wow. I don't know. I don't know. That's praise. Okay, that makes sense now. Praise. Praise. Okay. Is that what bear photo? No. Right? That should be red. No flash photography, right? No flash photography. No cap. Is that a cap? Gosh, that's a horrible cap. But it's not too bad. Look. Hey, play ball. Let's go watch the Cubs. All right. All right. All right. I'm just afraid of the Kodiak. I don't want to get near it. We have 10 minutes. All right. This one doesn't look too harmless, right? All right. So there, I'm going to draw my long stick, and now we're going to poke the bear, right? Poke the bear. You can't get me. I'm in Idaho, right? And he calls his bear friends in Idaho. Get that guy, right? Look out, Mr. Carl Donahue. The bears are after you. You're on the bear blacklist. Which side do you want to start on, left or right? Or should we let sleeping bears lie? Yeah, this one's not sleeping, though. He's already up. Oh, but you're right. Let sleeping bears lie. What'd y'all say? Left? Okay. What would y'all do on the left? Would you get a common denominator, or would you put it in terms of sine and cosine? Or would you run the other way? I mean, you don't even know looking at this one that it's that bad. This one's still sleeping, essentially. Well, no, you don't know that. It could be like a two-line proof, and I'm just like pulling your leg. Like, how did that become like a joke? Like, someone's grabbing your leg and just like yanking on it, and you're like, hey, quit joking with me, man. Like, how did that become a joke? He could be pulling your leg because he's dragging you, somewhere you don't want to go. You're going to the dentist. Quit joking with me. What would you do? Put it in terms of sine and cosine or get a common denominator? I'm asking you. You have enough experience now. Butterfly, butterfly. Let's do that. Let's do the butterfly multiply. Okay, because the LCM is their product. Tangent times 1 plus tangent. Tangent of x, right? Small. Plus okay, don't write small. You have pages to add. Just make sure you have lots of memory so you can store all these things. Over their product, 1 minus cotangent times 1 minus tangent. Okay, that looks good. That looks real good, I guess. Now what? Should we distribute? Now you want to, okay, the top is partially factored, so we'll distribute. That's tangent of x minus tangent squared plus cotangent of x minus cotangent squared. And on the bottom, do you want to leave it factored or distribute? Remember, the top was partially factored, so it made sense to expand it. Yeah, I know. Let's just leave it for now, huh? Let's just leave it. 1 minus cotangent, 1 minus tangent. All right, is there any obvious thing in the top? Can we combine like, can anything combine? Baby pid? Adonde? Oh, yeah. Yeah, you can replace tangent squared with cotangent squared minus 1. You want to do that? Sure? Okay, I heard a sure. That's all I need. So, in parentheses, tangent squared is secant squared of x minus 1 plus cotangent minus cotangent squared. Can we do anything with tangent plus cotangent? Can we call that 1 because they're reciprocals? No, very good. They're added, not multiplied. All right, so now if we distribute, we get tangent of x. Oops, I need the denominator still. Let me go ahead and just copy that because it's already factored. I'm just going to kind of rewrite it every time. And again, people in the days of old, they had to like write this by hand, and they couldn't really use purple unless they had a purple pen. If we distribute now, why did we do that? Oh, you said sure. That's right. That's introducing a whole nother trig function to this, right? Which I kind of want over here, huh? So maybe that's not stupid. I should probably change cotangent then at the same time, huh? Yeah. No? I don't know either. You know, that's not really an informed decision. Here's what I'm going to do. I'm going to get rid of that. And look, I have to hit eraser and then just tap. Everyone in the old days like, oh, I'm already on my 4th eraser. My dad had to buy me some new ones over the weekend, right? Okay. It was a funny laugh. I don't know if the recorder picked it up or not, but all right. Hey, what do we have on the left side that we don't have on the right side? A single term? Yeah, let's go over there and get a single term. Well, it's over 1. Well, how can we kind of jumpstart it? How can we put secant and cosecant in terms of fractions? Yeah, how about 1 over cosine times 1 over sine? And now we can call 1 cosine times sine. And then we can say plus 1 times 1 is 1, all over cosine times sine. Are you okay with that? That's what that becomes. We got a common denominator. 1 becomes cosine x sine x over cosine x sine x. You add the numerators and you put it over the common denominator. Well, I'll be a monkey's uncle. Now, what do we have on the right side that we don't have on the left? Put in terms of sine and cosine. So maybe now we'll jump back over here and put in terms of sine and cosine, which maybe we should have done that in the beginning. Oh, crap. Do you want to go back and put it in terms of sine and cosine in the beginning now? Or just try and work with all this? Okay, let's forge ahead. Very good. I mean, we can. We saw on the previous one that, you know, we're waking up the grizzly bear, by the way. I mean, it's starting to look pretty mean and feisty and ugly. But no big deal. There was a guy several months ago that was running on a trail and he got attacked by a juvenile mountain lion. And because he was not listening to music, he didn't have earbuds in, he heard it kind of, the footfalls, the silent, deadly footfalls falling behind him. And he was able to turn just in time for it to spring up and grab him. And he was able to put his right arm up. And the juvenile bit his arm, his forearm, and clamped down. And they started struggling. and they rolled off the mountainside in the struggle, rolled down to a little rock ledge that was down below, and they fought for a while. And here's what happened: if it were me and I had his arm in my mouth, I would have been there and I would have been trying to like gouge out his eyes and break his neck. You know, like in the movies, like the mobsters, they come up and they're just like, now you sleep, right? I would have been trying to do that with the mountain lion unsuccessfully, and I probably would have died. But what this guy did is he had the arm, and they were struggling. He held him down with his right arm, and he was able to stand up while this thing was on the ground eating his arm, and he stepped on his neck and while he's hunched over, like his arm is on the ground, and now he steps on the guy's neck, or the dude. Yeah, it was a juvenile male. Yeah, the dude's neck, and he just kept like bouncing and pressing on the neck with all of his weight until he choked out the mountain lion, and it ended up dying, and he was able to live. So, but you know what? This is not a mountain lion. This is this guy. So I do not think we're going to be able to. Yeah. So we're essentially finished with this. I will finish this one as an activity. I would encourage you to do the same. And we'll just look at it tomorrow. I'm not going to give you one this ferocious on your test because it falls outside the scope of what a 50-minute test should be. Okay? But this would be an excellent like take-home problem. So enjoy the rest of your day. Make sure you finish section 6.2. There are no Kodiaks on it.